With the help of an activity, it is easy to visualize geometrical aspects. Hello students, today we are going to verify basic proportionality theorem, also known as Thales theorem, with the help of an activity. To demonstrate this activity, we have made an assembled model in which two graduated scales are attached parallelly to each other to a wooden base, and between these two graduated scales, a scale is attached which is parallel to the base, supported by these two pulleys. Now students, what do you mean by basic proportionality theorem? Basic proportionality theorem states that if a line L is parallel to any one side of a triangle to intersect the other two sides of a triangle at distinct point, then the other two sides are divided in the same ratio. We are going to verify this basic proportionality theorem in 4 cases: when we have a scalene triangle, a right angle triangle, an isosceles triangle, and an equilateral triangle. So let us take case 1, when we have a scalene triangle. Now you can see that this is a scalene triangle ABC, and this scale which is representing the line L is parallel to the side BC of this triangle A, B and C. Let us adjust the scale at some position. Now you can see that this line is parallel to the side BC and intersecting the other two sides of the triangle ABC, where it is intersecting the other two sides of the triangle AB at say E and AC at F. Now we have to see whether it AE by EB, AF by FC are same or not. Now on measuring AE, EB, AF and FC, we can see that. On measuring AE, we can see that AE is how many units? 4 units. EB is 8 units. Similarly, on measuring AF, we can see it comes out to be 6 units. It was AF, it is 6 units, and FC is 12 units. Now on calculating, as we can see, AE by EB is equal to 4 by 8, which is equal to 1 by 2. AF by FC is equal to 6 by 12, which is again coming out to be 1 by 2. This shows that AE by EB is equal to AF by FC, which shows that the other two sides are divided in the same ratio. Now let us take for some other position, say suppose here. Now this again you can see in this that this scale which is representing the line L parallel to BC and intersecting the other two sides, that is AB, say at some position say G, and AC at say suppose H. Now you can see again on measuring AG, GB, AH and HC that whether the two sides are divided in the same ratio or not. On measuring AG, we can see that AG is coming out to be 8.4 units and GB is 3.6 units. Similarly, AH is coming out to be 12.6 units and HC is 5.4 units. Again, by mathematical manipulation, we can see that AG by GB is 8.4 upon 3.6, which is coming out to be 7 by 3, and AH by HC is 12.6 upon 5.4, which is again coming out to be 7 by 3, which shows that the other two sides are divided in the same ratio. Now let us take for the another case. Let us take for the right angle triangle. This is a right angle triangle PQR, right angled at Q. Let us take some position, say suppose at this point. Again you can see in this triangle PQR, this line L is parallel to QR and intersecting PR, say suppose at, let us write it as D, and PQ at, say suppose E. Now on measuring PD, DR, PE and EQ, we can see whether the two sides are divided in the same ratio or not. So on measuring PD, we can see that it is how much? 6 units, and DR is how much? 18 units. Similarly, on measuring PE, we can see that it is 5 units and EQ is 15 units. Now, by mathematical manipulation, we can see that PD by DR is 6 by 18, which is coming out to be 1 by 3, and PE by EQ is 5 by 15, which is again coming out to be 1 by 3, which again shows that the other two sides are divided in the same ratio. Now, you can repeat this process by putting the scale up and down and verify yourself that whether the corresponding ratios are equal or not. Now, let us take the third case for isosceles triangle. So, you can see that this is an isosceles triangle STU. Let us adjust at some position, say suppose here. Since it is isosceles triangle, so this you can see that ST and SU are equal. This line L is again parallel to TU and intersecting the other two sides of a triangle STU at, say suppose again G and H, where ST is intersect, or we can say where line is intersecting ST at G and line L is intersecting SU at H. Again we can see that on measuring SG is how much? 10 units and GT is, we can see 13 units. SH is also 10 units and HU is also 13 units. So, it is clear that the ratio of SG by GT is 10 by 13 and also the ratio of SH by HU is 10 by 13, which again shows that the other two sides are divided in the same ratio. Let us take the fourth case, where our triangle is an equilateral triangle. Now, you can see that this is an equilateral triangle with all the three sides are equal, W, X, Y. And again, this line L is parallel to XY, intersecting WX and WY at different points, or we can say distinct points. So, again by pulling the scale up and down, take the different position and verify yourself whether the corresponding ratios are equal or not. This is how we have shown that whenever a line L is parallel to any one side of a triangle, intersecting the other two sides at distinct points, then the other two sides are divided in the same ratio. This verifies our basic proportionality theorem. Thank you.